Okay, so today we are talking about how to solve quadratic equations by using square roots and also by completing a square. We also want to be able to write quadratic functions in vertex form. So completing the square. I heard from my other classes that you guys have heard of completing the square before, right? So this part of this will be a little bit of a review for you. So what completing the square means is if we start with a binomial of the form x squared plus bx, and we're going to turn it into a perfect squared trinomial. Let me show you some perfect squared trinomials. This would be one. A perfect squared trinomial means that when I go to factor this, I put x and x. What numbers multiply to be 16 and add to be 8? 4 and 4. The reason this is called a perfect square trinomial is because it's a trinomial, 3 terms, that end up being a perfect square. Alright, let's look at another one, see if you guys would know what this one would be. What about if you had x squared minus 10x plus 25? You know how that would factor down? What's it going to be, Riley? Do you notice the relationship between this middle number and that number? Like, I just made these up off the top of my head, and how would I know what number to put there if this is a 10? It's half of it, but then it's also squared, yep. And that's what it's saying right here, is that to complete the square of this expression, you're going to take this value right here, divide it by 2, and then square it. It's right there for you. And this is just the actual formula. If we have x squared plus bx plus half of b squared, this is the way it's always going to factor down. All right, so what we're going to do is we're starting with a quadratic that's in standard form. We want to be able to write it in vertex form. So it's in standard form. We could find the vertex by doing negative b over 2a, but that's a hard way of doing it. So here's what we're going to do. We've got f of x equals x squared plus 4x. We're going to move this constant down and out of the way. What number would I have to put right here in order to make this a perfect square trinomial? What number would have to go right here? Take half of this and square it. What do you get? It's half of 4 squared. So I'm going to put plus 4 here. But I'm not allowed to just go around adding 4 to equations because it's not equivalent. So if I'm going to add 4 to this spot, I'm grouping these together, what am I going to have to put right here to keep it the same? Minus 4. Right? If I add 4, I have to subtract 4. So finishing this then, I'm going to have f of x equals. How does this factor? If you don't know, come over here to the side. We're trying to factor this. So I'm going to set up my double parentheses, x times x. What numbers multiply to be 4 and add to be 4? 2 and 2. And I have to get a positive 4, so plus and plus. So what is another name for this then? X plus 2 what? Squared. And then 5 minus 4 is just 1. So my vertex form is this. See how now I can immediately see the vertex is going to be negative 2, 1. Okay? That's the whole purpose. Now I don't have to do negative b over 2a, which is negative 2, and then plugging it in, I would get 1. This is a faster way to find that vertex instead of doing the negative b over 2a. All right, let's do this one together now. So we've got f of x equals x squared plus 10x. I'm going to move this 28 out of the way. What am I going to put here to make it so that I can complete the square? 25. How did you get that? What do we do? Take half and square it. Half of 10 is 5. 5 squared is 25. So if I'm going to add 25, I'm also going to have to subtract 25 because they're on the same side, right? So if I'm adding 25 to this side, I'm also going to have to subtract 25 from that side. Now, it would just be exactly the same thing as it was at the beginning. All right, so now let's see if you guys can simplify that and tell me what you would get. Anybody know what that would simplify to? What's it going to be, Sona? Good job. So that would be vertex form. Questions? All right, let's go over here. Solve the equations by using square roots. All right, here's how we're going to do this. This right here should be a perfect square. What is another name for this? How would this factor? X plus 2 squared is right. All I have to do is square root this sign, square root. I have something squared equals 2, so I could take the square root of both sides. The square root of something squared is just x plus 2. This has to be plus or minus radical 2, and then I take the 2 over. This would be the solution. There are two solutions, negative 2 plus radical 2 and negative 2 minus radical 2. There are actually two solutions there. All right, look at this one. A little bit more challenging. Maybe you want to set up your double parentheses here. I'm not going to set it equal to 0. I'm just going to leave it like this. What times what gives me 9w squared? And then numbers that multiply to be 1. My outers and inners have to combine to give me 6. Positive 6. So what are the signs going to need to be? Positive on both. So now I'm going to have 3w plus 1 quantity squared equals negative 18. Now I'm going to have to take the square root of both sides. If I have the square root of something squared, it's just going to be 3w plus 1. I don't need parentheses anymore. This is going to be plus or minus 3i radical 2. Do you guys see how I got that? Now solving this, I'm going to have to subtract 1 from both sides. So now I've got 3w equals, I like to put this first because that's the real part. Negative 1 plus or minus 3i radical 2, but I still have 3w, so I have to divide the whole thing by 3. These are going to be my answers then. I'm going to have negative 1 plus or minus, but watch what I can also do. I can split this apart. Negative 1/3 plus or minus, all of this over 3 would just be I radical 2. This is the best way to write that solution. Look what I did. Negative 1/3 plus or minus, all of this over 3, the 3's would cancel, so I would just get I radical 2. This has to be over 3, and this term must be over 3. That's a tough one. You might want to go back and look again. All right, next part. Find the c-value that makes the expression a perfect square trinomial. Then write the expression as the square of a binomial. So what's going to go in this spot then, guys? 49, right? And then to factor it, we just can do it quickly. Square root, first sign, square root. That's all it's going to be. Now we're going to have an odd number. It's the same kind of thing. I have s squared plus 17s. I have to take half of 17, but I'm not going to call that 8.5, and I'm not going to call that 8.5. I'm going to leave it as 17 over 2. Now I'm going to square it. 17 squared is 289. and 2 squared is 4. So that's what the C value would have to be. I don't want to take half of 17 and put 8.5. I just want to leave it half of 17, 17 over 2, square this, square that. The way this would factor, square root of this sign, square root of that. And there we go. All right, let's do some problems now. Solve the equation by completing the square. If I'm going to complete the square, I take this over here. I'm going to take half of this and square it. That's 9. I add 9 here as well. The reason I added 9 to both sides is because they're on opposite sides. So if I'm going to add 9 to this side, I add 9 to this side to keep it equivalent. So now finishing. This is going to be square root, first sign, square root, equals 11. To get this to solve for r, I'm going to take the square root. I have r minus 3 equals plus or minus radical 11. I'm going to add 3, and I want to write it in the correct form. I like to have the whole number part come first, followed by the irrational part. All right, next one is a little tougher. I have to distribute this out first. I get y squared plus y. I keep that over there. I have to take half of 1. Well, half of 1 is 1/2. So what am I going to put here? What is it? What's 1/2 squared, you guys? 1 over 4. So if I add 1/4 here, I have to add 1/4 here. So now the way this is going to factor is square root, first sign, square root, equals 1. Take the square root of both sides. Y plus 1/2 equals plus or minus 1. Subtract 1/2. Positive 1 minus 1/2 is 1/2. Negative 1 minus 1/2 is negative 1.5. All right, I just want to show you, I'm not going to do the whole thing on number 7, I just want to show you something. So if I multiply this out, I get 6x squared plus 30x equals negative 24. Yeah. No, it's because that's not right. See, this was plus or minus 1, so 1 minus 1/2 is 1/2, but negative 1 minus 1/2 is negative 1.5. The answer isn't plus or minus 1/2. Guys, this is one I just wanted to talk about what you need to do first before you even start the problem. The coefficient of x squared has to be 1 in order to use completing the square. So what would you have to do first before you even started this problem? Divide by 6. Because it's an equation, I can divide every term by 6. And I changed my mind. I'm going to do the whole problem. Here's why I want to do the whole problem, is because of this. When this number's odd, it's a lot harder of a problem. Half of 5 is 5 over 2. What am I going to put here then? 5 over 2, guys, and I have to square it. 25 over 4. I got to put that here, and I have to put that here. So factoring this, I do the first square root, this sign, and then this square root. That's always the fastest way to factor it. What would I have to do here to be able to combine? Get a common denominator. So this would be negative 16 over 4 plus 25 over 4 would be 9 over 4. Okay, so now I'm going to take the square root of both sides, and I have x plus 5/2 equals, what's this going to be, guys, the square root? Plus or minus 3 over 2. Now I'd have to subtract the 5/2. And so I'm going to have 3/2 minus 5/2. Well, that's negative 2/2, which is just going to be negative 1. And then I have negative 3/2 minus 5/2. That's negative 8/2. What's negative 8/2? Negative 4. Those are my two solutions. When I get nice solutions like that, what do you think that means about the very beginning part? It could have been factored. I could have just factored it, is what that means. When I get nice whole number answers, even this one could have been factored, is what that would imply. All right, let's look at this one. This would be an ACT problem, probably in the back. There are always 60 ACT questions. This would probably be something like number 56, because it's a pretty challenging one. They might ask you to simplify something like this. Does anybody have any ideas of what this really is? What do you get if you take half of 8 and square it? What do you get? Half of 8 is 4, and then square it is, okay? So this would really be a perfect square trinomial, and they tell us that. So how does the pattern go then? What do we do with the first term? What do I keep saying we do with that first term when I go to this part? Take the square root, so this would have to be 4p plus 1. I use the first sign, and then what do I do with this? Take the square root, so it's 4, and then it's quantity squared. So what is another name for it then? Yeah. This is another name for it. So like on the ACT, they might give you this and then say, which of the following is equivalent? And they'd have all these different options. You would have to be able to tell, oh yeah, that's a perfect square trinomial, just do that quickly. You could do this by, oh my gosh, I used to, last year I gave people a lot of time to do this problem, and everybody just squared this out, distributed this, combined like terms, and then they factored it. That was fine, but can you think of how long that's going to take you to do it that way? Doing well on the ACT is all about recognizing patterns. So if you can recognize that pattern, that's going to save you a ton of time. All right, let's go to the back. Determine whether you would use factoring, square roots, or completing the square to solve the equation. Then solve the equation. This one, guys, this we are not going to complete the square on. It's easy to factor. I'm just going to look for a greatest common factor. Because it's already set equal to 0, it's easy just to factor out an x. X squared divided by x is x. 7x divided by x is 7. Now we're just going to set each of these equal to 0. There's our two solutions. We've had similar problems to that on our weekly reviews, so that should look familiar, that concept. What about number 10? What's the easiest thing to do? Quantity squared equals a number, so take the what? Square root. So I take the square root, take the square root. X minus 1 equals plus or minus radical 35. Bring over the 1. So x is going to be 1 plus or minus radical 35. What would you want to do first on this one? It's an equation. I'm allowed to divide. What can I divide by? 4. So now it's going to become x squared plus 2x plus 3. This looks like it could be factored. Are there numbers that multiply to be 3 and add to be 2? Not add to be 2. They would subtract to be 2, but not add to be 2, would they? So this can't be factored. It almost looks like it could be, but there are not numbers that multiply to be 3 and add to be 2. So I'm going to have to do this. I'm going to do it kind of quickly. I'm going to take half of this and square it. If I add one here, I add one here. Another name for this is square root, first sign, square root. This is -2. I take the square root of both sides. This is x plus 1 equals plus or minus I radical 2. So my solution then is going to be x equals -1 plus or minus I radical 2. So this has two imaginary solutions. Two imaginary solutions. So that would tell me it has no x-intercepts because these are imaginary solutions. See, this one would have x-intercepts if I were to, bring everything over and set it equal to f of x. All right. The area of a triangle is 30. Find the value of x. Okay, that doesn't really make sense. I think I'm missing something here. What are we trying to do here? I don't know. We must have had a diagram that didn't copy or something. All right, let's go down to number 13. Write the quadratic function in vertex form, then identify the vertex. You guys think you can do this? Vertex form? Try it out on your own. Did you guys get it right? Yes? No? Any questions about it? Let me show you another cool way you can do this. If I have y equals x squared plus 6x plus 22, wouldn't this be equivalent? Y equals x squared plus 6x plus 9 plus 13. Is that equivalent to what I started with? Is 9 plus 13 22? Can you see how I just split 22 up into 9 and 13? And so now see how I kind of skipped that step and I could go directly to this? See how I get the same thing there? Kind of neat way to do it. When I'm doing this on my own, that's the way I do it. I take this number and I think, okay, half of this is squared is 9. So I want to have a 9 here, so 9 plus what would give me 22? Just another way of thinking of it. If that confuses you, just ignore it and do it this way. But kind of neat. Do you guys like it or confusing? Be honest. Which is it? Confusing? All right, never mind. Gone. Pretend you never saw it. All right. A golfer hits a golf ball on the fairway with an initial velocity of 80 feet per second. The height h in feet of the golf ball t seconds after it is hit can be modeled by the function h of t equals negative 16t squared plus 80t plus 0.1. Find the maximum height of the ball. Guys, when we have a problem like this is telling us probably to go to the calculator. This would be a pretty tedious problem to do without. We've done this before, but just to refresh your memory on what we do, we're going to put this in to our y equals. So we put this in. I have to use x instead of t, of course. I'm going to do a zoom 6, a zoom standard. Here's what the path of the golf ball is, but I'd like to be able to see the top of it, so I'm going to change my window. I'm going to make my y max bigger. I don't know what it needs to be, maybe 50. My x-min, that can be 0 because we're talking about time here, so I'm going to make it 0. Now let's hit graph. Ah, that wasn't enough. I got to wait for it. Okay, so y max needs to be bigger still. I'm going to go to 150. That should do it. There we go. Alright, so here's the golf ball, finding the maximum height. You guys remember how to do that? Second, trace, calculate. What am I looking for? Maximum. I go over to the left. It's asking for the left bound. I hit enter. Go over to the right. Hit enter. One more time. So this number right here is the maximum. 100.1. That's going to be its maximum height. How long does it take for the ball to hit the ground? What is the height when it hits the ground? 0, right? So I want to know what's that height when y is 0. Here's what I can do. I can go to y equals and I can put in 0. This is the easiest way to do it. I want to know when is my function equal to 0. So I'm going to hit graph. And I'm trying to find this number right here. How long does it take? Second, trace, calculate, the intersect. I get close. Oh, that's nice. It went right to it. Enter, enter, enter. And 5.001 seconds. That would be to the nearest thousandth place. Okay? Any questions? Use the calculator on problems where it would be very difficult to complete the square or factor. Just go ahead and use your calculator on those, especially word problems. Pretty much any word problem I'd use the calculator.